number 9. 3 more questions for the day. So just above our halfway point here. Question 9. It's asking us, draw the graph of f of x equals 0.5x plus 3 minus 4. Okay. So I'm going to say graph f of x equals 0.5 times x plus 3 minus 4. So before we graph this function here, I could actually simplify this algebraic expression, right? I have f of x equals 0.5x, and this here I have this plus 3 minus 4 here. I can actually do this operation in the brackets, right? 3 minus 4 here is simply just -1, so this here would equal -1, right? So f of x equals 0.5x minus 1 here. So what we have to do when we're graphing this solution here, we could actually change f of x here into y, right? Just to for our purposes here. Let's change this to y. And what we're going to do first is we can solve for some intercepts and whatnot, right? Well, we know here first is that this already is in slope y-intercept form, right? This guy here is our slope, and this guy here is our y-intercept, right? So we know these guys already exist. So what I have to do next is I want to solve for my x-intercept, right? So these are all components we need before we graph. So if I want to solve for our x-intercept here, what I'm simply going to do is I'm going to set y to 0, right? So I'm going to say that, so this is set y equals 0. So I'm going to say if y equals 0, then I have 0 equals 0.5x minus 1. And then I can simply move, and then I'm just algebraically rearranging for my x value now, right? Because I'm solving for the x-intercept. -1, I can move this over to the other side to make this +1. So this is +1 equals 0.5x. And I can divide both sides by 0.5, right? So 1 over 0.5 equals x. So therefore, you can say x here is going to equal 2, right? So this here is going to be our x-intercept for our graph. This here is our, oh, I'm not going to box this because this isn't our answer yet, but we have our x-intercept as well. So I can say here x would equal 2. And finally, now we can graph, right? We're given three types of information, so we can probably graph. So I'm going to sketch this graph, and I'll actually show you on Desmos what this graph actually looks like without the sketch. So I have here my intercepts here. I have, again, -1 is going to be my y-intercept. So let me write out -1 here. Y, here is x guy. This is -1. And my x-intercept here is 2, right? So I'm going to say 1, this here is 2. So it's going to come, I know I have a point here, also a point here, and it's going to be negative, this here is -5, right? -0.5. Or no, sorry, it's positive 0.5 is our slope, right? So you can think of it as our slope, it's increasing by 1 over 2. So you can say I'm going up by 1 and then over by 2. So these 2 points are correct. So my next point would be up by 1, which is at 1, and then right by 2, right? So this would be 3 and 4. So my next point would be kind of, here. So remember this, you can think of our slope here. Our slope is really important, right? If 0.5 is our slope, you can also convert this to half. This here is our rise over run. So when we talk about rise, our numerator here is rise. So we go up by 1, and then we go, our run here is either left or right by 2. In this case, it's right because I have a positive slope. So this solution here is correct. I have 3 points in my graph now, so I'm simply just going to draw a line from here to here. And this will connect, hopefully, all of these points here. And this here is my graph of, this here is f of x. This is the graph of f of x equals 0.5x plus 3 minus 4 here. And what I'm going to do is I'm going to bring out Desmos, and I'm going to verify this graph for you as well. So let me bring up Desmos for us. And this, if you don't know what Desmos is it's actually a graphing kind of a calculator, and it helps you visualize functions here. So I usually do use this to just check my answer and to show you with colors what this function looks like. So f of x here, I'm going to type in 0.5x plus, in the bracket, 3 minus 4, right? And as you can see, this here is our graph, right? So here's our beautiful graph of 0.5x plus 3 minus 4, or you can say simply 0.5x minus 1. And as you can see, I can visualize these 2 points, right? These 2 points here are 0 and -1. And like my graph here, I have this point is also 0 and -1 here. And this here is 2 and 0. These two are my intercepts here. And as you can see, the next point, like I've chosen here, would have been 1 and 4, right? So let me maximize it for you. 1 and 4 here would have been my next point here. This is 2 and 0. This is 0 and 1. So as you can see here, this solution here is correct. So the graph here is very, very accurate. And again, it matches my Desmos graph here. So this solution, let me draw this out here. This solution looks correct. 0, 1, 2, 0, and this is 0.5 minus x here. So this solution looks correct as well. So solution is correct. Good analysis here.